This video will cover difficult questions relating the topic of integration inverse trigonometric functions. Question 1. The first four integrals I will explain are all involved with arcsine. They are different styles, but look at how to integrate with arcsine using substitution. Rewrite it as two fractions. The integral of 4x over square root of 3 minus x squared dx minus integral of 5 over square root of 3 minus x squared dx. For the first integral, use substitution, while the second integral involves arcsine. Let u equal 3 minus x squared, derive on each side, du equals minus 2x dx, then times minus 1 on each side, minus du equals 2x dx, then times 2 on each side, minus 2 du equals 4x dx. Change all x into u equals the integral of 4x dx is minus 2 du over square root of 3 minus x squared is u. Then minus 5 moves here. The integral of 1 over square root of 3 minus x squared dx equals minus 2 moves here. Integral of, rewrite as the power form, u to the power of minus 1 over 2 du. For the second integral, use the formula. The integral of 1 over square root of a squared minus u squared du equals arcsine of u over a plus c. In here, a squared equals 3. That means a equals square root of 3. Then u squared is x squared. That means u equals x. Then minus 5 arcsine of u over a, u means x, over a means square root of 3, plus c equals minus 2 times, using the power for integration, u to the power of 1 over 2 over 1 over 2 minus 5 arcsine of x over square root of 3 plus c equals minus 2 times 1 over 1 over 2. That means 1 divided by 1 over 2 equals 1 times upside down 2 over 1, which is 2 over 1 equals 2. Then u to the power of 1 over 2 means square root of u minus 5 arcsine of x over square root of 3 plus c. The final answer is minus 4 square root of u was 3 minus x squared, then minus 5 arcsine of x over square root of 3 plus c. Question 2. Do you think the integral has to be divided into two fractions as in question 1? We can rewrite as the integral of x over square root of 6x minus x squared dx plus the integral of 1 over square root of 6x minus x squared dx. Of course, the first integral uses u substitution. Then let u equal 6x minus x squared, then derive on each side, du equals 6 minus 2x, then dx. there is only x dx, then take out minus 2, du equals, you can factor, minus 2, then x minus 3 dx, divide by minus 2 on each side, du over minus 2 equals x minus 3 dx. How is it? We need x minus 3 dx, not x dx. So when we find this integral problem with u substitution, we have to think about what du is first. So we don't need it. Now we know we need x minus 3 dx and minus 3 plus 3 here, just the thing adding 0. Then we can write the integral of x minus 3, then plus 4 over square root of 6x minus x squared dx. Then make two fractions. The integral of x minus 3 over square root of 6x minus x squared dx plus the integral of 4 over square root of 6x minus x squared dx. Antiderivative of the first one, change all x into u. The integral of x minus 3 dx is du over minus 2, then 1 over square root of 6x minus x squared is u, plus 4, the integral of 1 over square root of, we can write the inside of the square root 6x minus x squared as the difference of the two squares. Then take out the negative sign, minus x squared minus 6x. Using the completing the square, the coefficient of the middle term, minus 6, divided by 2 equals minus 3, then squared equals 9. So minus x squared minus 6x plus 9 minus 9. Like adding 0 equals minus, only this part makes perfect squared form, x minus 3 squared minus 9, then expand. The first one, minus x minus 3 squared, then next one, plus 9. Then back to the original, 9, then minus x minus 3 squared dx equals 1 over minus 2, the integral of, make the power form, u to the power of minus 1 over 2 du. Now use u substitution. I already used the letter u, so this time I will use the letter w. Then let w equal x minus 3, then derive on each side, dw equals dx. Then change all x into w, plus 4, the integral of 1 over square root of 9 minus x minus 3 is w, then squared, dx is dw equals minus 1 over 2 times integral of e to the power of minus 1 over 2 is, using the power for integration, e to the power of 1 over 2 over 1 over 2. Now use the formula, the integral of 1 over square root of a squared minus u squared du equals cosine of u over a plus c. In here, a squared is 9. That means a equals 3. Then u squared equals w squared. That means u equals w. So plus 4 times cosine of u over a, u means w, over a means 3 plus c. The final answer is 1 over 2 is cancelled, minus u to the power of 1 over 2 is square root of u. Then u is 6x minus x squared plus 4 arc sine of w is x minus 3 over 3 plus c. Question 3. We can write the inside of the square root as a difference of the squares. 5 plus 4x squared minus x to the power of 4 equals 5 plus 4 times x squared minus x squared then squared. Then let a be x squared. So 5 plus 4a minus a squared. Then 5 with these two, take out the negative sign, minus a squared minus 4a equals 5 minus a squared minus 4a. Then the coefficient of the middle term is minus 4. Then minus 4 divided by 2 then squared equals minus 2 squared equals 4. Then plus 4 and minus 4. The same as adding 0. And 5 minus only this part make perfect squared. Then minus 4. Then expand 5 minus a minus 2 squared. Then plus 4. Then finally 9 minus a minus 2 squared. And then 9 minus a was x squared. So x squared minus 2 then squared. Then back to the original, the integral of x over square root of this one is this. Now 9 minus x squared minus 2 squared dx. Now use u substitution. Let u equal x squared minus 2. Then derive on each side. Du equals 2x dx. But there is only x dx. So divide by 2 on each side. Du over 2 equals x dx. Now change all x into u. The integral of x dx is du over 2 times 1 over square root of 9 minus x squared minus 2 is u, then u squared. Then we can rewrite as 1 over 2, the integral of 1 over square root of 9 minus u squared du. Then use the formula, the integral of 1 over square root of a squared minus u squared du equals arc sine of u over a plus c. In here, a squared is 9. That means a equals 3. So 1 over 2 arc sine of u over a. u over a is 3 plus c. The final answer is 1 over 2 arc sine of u was x squared minus 2 over 3 plus c. In question 4, what we need to evaluate now is the definite integral. Let u equal square root of x plus 1. Do you remember we need du, but we are not doing differentiation here. It's much easier and faster to find du by squaring both sides than differentiating it. So shall we? U squared equals x plus 1. Then derive on each side. 2u du equals dx. Evaluating the definite integral using substitution is that when a variable changes, the limits of integration for x is also changed to integration limits for u. From here, when x equals 2, then u of 2 equals the square root of 2 plus 1, which is the square root of 3. So the new upper limit is the square root of 3. Then when x equals 0, u of 0 equals the square root of 0 plus 1, which is 1. The lower limit is 1 now. In here, minus 1 on each side. Then u squared minus 1 equals x. Then 3 minus x equals 3 minus x is u squared minus 1. Then expand, u squared plus 1 is 4 minus u squared. So square root of 3 minus x equals square root of 4 minus u squared. Now change all x into u. The integral of upper limit 2 is now square root of 3. The lower limit is 1. Then dx is 2u du over 2. Then square root of 3 minus x is square root of 4 minus u squared. Then square root of x plus 1 is u. Then we can rewrite as from 1 to square root of 3, 2 is cancelled, u is cancelled. Then 1 over square root of 4 minus u squared du. Now use the formula, the integral of 1 over square root of a squared minus u squared du equals arc sine of u over a plus c. And in here, a squared is 4. That means a equals 2. Then equals arc sine of u over a. U over a is 2. The lower limit is 1. The upper limit is square root of 3. We do not return to the variable x after integrating. We just evaluate the expression in u using the changed limit of integration. So, arc sine of the upper limit square root of 3 over 2 minus arc sine of the lower limit 1 over 2. When theta is pi over 3, the ratio of the triangle is 2 square root of 3 and 1. Then sine pi over 3 equals square root of 3 over 2. That means arc sine of square root of 3 over 2 equals pi over 3. When theta is pi over 6, the ratio of the triangle is 2, 1, square root of 3. Then sine pi over 6 equals 1 over 2. That means arc sine of 1 over 2 equals pi over 6. Then back to the original. The first one is pi over 3 minus the second one is pi over 6 equals, make the same denominator, 2 pi over 6 minus pi over 6. Then final answer is pi over 6. We had 4 integrals involved with arcsine. Now let's do the integrals involved with arctangent. Since the degree of the numerator is greater than the degree of the denominator, we simplify it using long division. X squared plus 4, then dividend is x cubed plus 0x squared plus 6x plus 3. Then x squared times x equals x cubed plus 4 times x is 4x. Minus cancelled. The remainder is 2x plus 3. Then the dividend, x cubed plus 6x plus 3 equals divisor, x squared plus 4 times quotient plus remainder. Then divide by x squared plus 4 on each side, and x cubed plus 6x plus 3 over x squared plus 4 equals, make separate. The first one is x plus the second one is 2x plus 3 over x squared plus 4. Back to the original. The integral of this x plus, make two fractions. The first one is 2x over x squared plus 4 plus the second one 3 over x squared plus 4 dx. Then the integral of x dx plus the integral of 2x over x squared plus 4 dx plus integral of 3 over x squared plus 4 dx. The first integral is x squared over 2 plus, the second integral use u substitution. Let u equal x squared plus 4, then derive on each side, du equals 2x dx, then 2x dx is du over x squared plus 4 is u, plus the last one, use the formula, integral of 1 over a squared plus u squared du equals 1 over a arctangent of u over a plus c. In here, a squared is 4. That means a equals 2. Then u squared is x squared. So u equals x. Then 3 times 1 over a is 1 over 2. Then arctangent of u over a, u means x, over a is 2, plus c equals x squared over 2 plus the integral of 1 over u is ln absolute value of u plus 3 over 2 arctangent of x over 2 plus c equals x squared over 2 plus ln absolute value of u is x squared plus 4 plus 3 over 2 arctangent of x over 2 plus c. But x squared plus 4 is always positive, so we don't need the absolute value sign. So final answer is x squared over 2 plus ln the bracket x squared plus 4 plus 3 over 2 arctangent of x over 2 plus c. This is the last one. This integral is similar to question 2. We have to think about what du is first. So use u substitution. Let u equal x squared plus 4x plus 8. Derive on each side. Du equals 2x plus 4 dx. We need 2x plus 4 dx here. So plus 4 minus 4. it is equal to plus 0. Then we can rewrite as the integral of 2x plus 4 minus 3 and minus 4, which is minus 7 over x squared plus 4x plus 8, then dx. Then divide into two fractions, the integral of 2x plus 4 over x squared plus 4x plus 8 dx minus integral of 7 over x squared plus 4x plus 8 dx. Of course, the first integral is to use u substitution. The integral of 2x plus 4 dx is du over x squared plus 4x plus 8 is u minus the second integral involves arctangent. We can write the denominator as the sum of the two squares, x squared plus 4x plus 8 equals, the coefficient of the middle term is 4, then 4 divided by 2 then squared equals 2 squared equals 4. Then we can rewrite as x squared plus 4x plus, make separate, 4 plus 4, like this. Then we can rewrite as x plus 2 squared plus 4. Now this is the sum of 2 squared form. Then back to the original, the integral of 7 over the denominator is x plus 2 squared plus 4 dx. The integral of 1 over u is at an absolute value of u minus, now use u substitution, let w equal x plus 2, then dw equals dx, then back to the original, 7, the integral of 1 over x plus 2 is w squared plus 4 dx is dw equals at an absolute value of u was x squared plus 4x plus 8 minus, now use the formula, the integral of 1 over a squared plus u squared du equals 1 over a arctangent of u over a plus c. In here, a squared is 4. That means a equals 2. U squared is w squared. That means u is w. Then 7 times 1 over a is 1 over a is 2. Then arctangent of u over a, u is w, a is 2, plus c. And the final answer is ln x squared plus 4x plus 8 is this one, is always greater than 0. We don't need absolute value sign, just bracket x squared plus 4x plus 8 minus 7 over 2 arctangent of w is x plus 2 over 2 plus c. I hope this video has been helpful. If you have any questions, leave them in a comment below. Thank you for watching. Please like and subscribe for more.